Let me ask you something. If I gave you two news articles covering the exact same news event, one from CNN and another from Fox News, could you tell me which one is it from? Most people can, intuitively. But can a machine do it? And more importantly, can it do it at scale without fatigue and without its own political opinion getting in the way? Why this getting is very important because with the rise of AI, the political polarization and the number of propaganda that is being spreaded through the news articles has also increased. So that is the problem I set out to solve. I have tried to solve it through a political bias detector model using deep machine learning. First, let me show you what I built and which is the first part of my project, the front end. It is a website where we can face the news and we can run our model. So this is the live application. Let me just orient you to what we are looking at before I do anything. This is a real-time political analyzer. It pulls live news, classifies it, and shows you where each source sits on its own political spectrum. For example, I'm going to face news now. So what's happening here is that the application is pulling news articles from multiple news sources and showing them straight away. And even before ML models even runs, you are getting the first layer of analysis. Source level bias labeling. These levels come from established media bias research organizations like All Sides and Adfontes Media. These outlets have spent years manually rating news sources. So CNN sits there, Fox News sits there, Reuters sits there. So this gives you a broad picture immediately. Now, quick note on what you are seeing. The news articles that I'm showing here are pulled from the News API. News API's free tier has a restriction on live production request. So that means that I cannot hit their API in real time for every user on a deployed application. So what I've done is that I have prefaced a set of articles, stored them in the PostgreSQL database, and the application serves from there. The classification pipeline, the model, the full analysis, everything works exactly as designed. The only constraint is that the data source with a paid news API plan, this feeds live articles in real time, as many as you want. So let's get back to our point. So we have seen the source level labeling, but the source level labeling is a bland instrument. It tells you where a source tends to lean on average. It says nothing about the specific article in front of you. A CNN reporter covering a natural disaster is going to write very differently from a CNN opinion columnist. Slapping the same level on both is very lazy, and this is the gap I'm feeling. So how to do it? So after the source level labeling, so what I'm doing is that I'm clicking on the deep ML classification. So let's wait a bit. So as you can see that it's now showing the AI level or the machine learning level. So this is the second layer, our article level classification from the fine-tuned Roberta model. Each model gets its own individual prediction based on the actual text. Watch what changes. Some articles stay roughly where you'd expect them given the source level, but some of them shift. That shift is the interesting part. That's the model picking up on framing, what choice, which voices are quoted, what context is included or left out, the things that source level ratings can never capture. The confidence score next to each level tells you how certain the model is. That score is calibrated. It's not raw model output. I apply temperature scaling at inference specifically so that when it says 85% confident, it actually means something. A model that is systematically overconfident is making exactly the kind of misleading claim that this tool is designed to expose. So what you are looking here is two layers of analysis side by side, established source reputation and the model's read on the specific piece of writing. Right now, the combination is more honest than either on alone. Okay, now let's get back to the citation network analysis of our application. So what you're looking at is the ecosystem of the news article. Every node is news source. The connections between them represent citation. When one outlet references one or links to another outlet in their reporting. So what the model does is color code everything by political bias. So you can immediately see the clustering. Look at how right-wing sources group together over there. They're citing each other, reinforcing each other's narrative, referencing the same stories through the same ideological lens. And you see the same thing in the left as well, its own cluster, its own internal citation loop. These are the echo chambers that have been made visible. This is not anecdotal, this is structural. Because of the limitations of the project, I have not been able to include many sources in this, but this is how the system works. Last but not the least, even though it's not part of the deep machine learning, I have also included a feature for the audiences to report any bias articles that they deem as a bias article. So to do that, a user can just log an article here. So that is another feature. So in the next part, I'm going to talk about the technological architectures that I have uh, used to build this system. So the system architectures has 5 layers: the client layer that we have just seen, the infrastructure, the presentation, the front end that we have seen, the application, the front end application, the back end application, and the data layer or the machine learning model. So we have already seen the user browser. I have used Nginx for the basic website security and segregating the back end and front end. And there is the front end using Next.js. And then this fast API backend, which I have used to both build the API system and the backend server. And I have also used the SQL database system to store my news articles to fetch it in real time. All right, and so about the dataset that I have trained my model one, there are 3 datasets, 26,000 samples after cleaning. The core challenge was that the each dataset used a completely different labeling scheme. So the dataset 1 and 3 only had 3 classes, dataset 2 had 5, and dataset 3 was massive, 16,000 samples, but it only had 3 classes, and keeping it at full size would have dominated the training data and kill the model's ability to predict center left and center right. So I downsampled it to 30% before merging. Everything then gets harmonized into a unified 0 to 4 integer schema before a single line of coding. So in the next part, I'll be going through my code base. So this is the training notebook. So everything that is running on the website came out of this. So let me walk you through it quickly. So first I do install the dependencies and confirm the GPU is there. It was a very computing intensive model, I would say. So I use 3 Kaggle datasets and I pull each one of them. And I needed all 3 because there's no single dataset that covered the full political spectrum well enough on its own. So each on filled a gap that the others basically left. So that is that. And after downloading the datasets and exploring it a bit, I understood, and this is where it gets really interesting, that all 3 datasets labeled political biases differently, different formats, different conventions. None of it agree with each other. So I wrote a separate loader function for each one that maps everything into the same 0 to 4 integer schema before anything else could take place. And for dataset 2 specifically, I concatenated the article title with the body before labeling, because the framing in a highlight headline carries as much as political signal as the article itself, and sometimes even more. Dataset 3 was of 16,000 samples, but it only had 3 classes, so no center left, no center right. So if I kept it at full size, it would swamp the training data, and the model would just stop predicting those 2 classes altogether. So I cut it down to 30% before merging, so which got me to around 26,000 samples total. So then I ran a cleaning pipeline. So before that, I do the level harmonizations, and after that, I ran a cleaning pipeline, 5 sequential filters. I dropped everything under 50 characters. I cropped everything at 5,000. I ran exact deduplication by MDF hash, remove near duplicates on the first 200 characters for articles that are same story, slightly rewritten, and strip out bare URLs and sub 10 word fragments. And the word, so the order matters. I deduplicated before anything took place. Okay, so even after merging 3 datasets, center left and center right were sitting under 3% of data each. So without fixing that, the model just defaulted to predicting centrist for anything ambiguous, because that's the safe option. So I oversample both minority classes to 15% and then apply inverse frequency class weights on top during training, and both together. And I did a stratified 70-15 split, and because without stratification, the rare classes was ending up underrepresented in validation, and the evaluation metrics become sort of meaningless. And okay, so after that, okay, I'll just quickly go through it. Okay, so this is the part that is very interesting, which is ordinal error loss function. So this is probably the most important cell in the notebook. So standard cross entropy actually treats every wrong prediction as equally bad, but political bias is fundamentally very ordinal. So being off by 1 class is not the same mistake as being off by 4. So I built a custom loss called ordinal error loss that adds a square distance penalty on top of cross entropy. The further the prediction lands from the true class on the spectrum, the heavier the penalty. So I tune lambda 2.3 on validation, and this is what that gave me the 93% adjacent accuracy. So when the model is wrong, it's wrong by 1 class, not 3. and I subclassed everything. I subclassed the Hugging Face trainer and override exactly one method, the compute loss, to plug in my custom loss, and everything else, the optimizer, the scheduler, the checkpointing, early stopping, all of that was inherited unchanged. For the training configuration, I set the learning rate to 2 for I learning rate to I configured the learning rate and ran for exactly 6 epochs with early stopping at patients 3, and I used the gradient accumulation. And this is the actual training cell online. So the best checkpoint by micro F1 when the validation set got automatically reloaded at the end. So I kept the best epoch, not the last one. So I evaluated on 3,920 out held out samples that the model never saw again, never saw before. So I got at 93.6% accuracy, 94% F1 macro, and 90% Cohen's kappa quadratic. Center right hit one recall, center left came at 98%. And to put that in context, the same model without the upsampling fix was scoring 81% on the class. So that's a 70-point improvement from one data decision. And it was not actually about better architecture or not more compute, just like I fixed the data. So I also ran calibration analysis. The model had EC of 1.163. So it meant that it was systematically overconfident. So I applied temperature scaling at inference with t equals 1.5 to correct that. So if I'm showing confidence score directly to the users, they have to actually mean something. So a model that's overconfident in making exactly the kind of misleading claim that the tool is built to detect. Then I do that error analysis. I pull the highest confident prediction, wrong predictions, and rate them manually. Most of them were genuinely ambiguous. So I ran some manual analysis. So okay, so also after doing everything, I saved the model in standard Hugging Face format. So there's configuration file, the weights file, and the tokenizers files. So then I took all of them to my backend. So I needed no further conversion, and the backend loaded it on startup. So after that, I'll just show my entire code base here a bit. So this is my political bias detector. So here is the backend, and here's the front end. So I put my previous data set into this file to make sure that everything works perfectly, and I deployed it on my personal server via DigitalOcean. So that's all about my project.